particular species of orchid is being studied. The population P at time t is after the study started is assumed to be P equals 2800 A e to the 0.2 t divided by 1 plus A e to the 0.2 t, where A is a constant. Given that there were 300 orchids when the study started, so t equals 0, show that A is 0.12. So P equals 300 when t equals 0. So let's substitute that into the formula. 300 equals 2800 2800a times e to the power 0.2 times 0. Well, 0.2 times 0 is going to be 0.
Mummy?
E to the power 0 is going to be 1. So that's going to just be like that. Divided by 1 plus a times e to the power 0.2 times 0 is that. So all of that is just going to be 1 as well. Now we just have a little equation to solve. So multiply both sides by the 1 plus a. So 300 plus 300a is equal to 2800a. Subtract the 300a from both sides. And divide both sides by 2500. So a is 0.12, which is what we needed to show. Part B. Use the equation with a equals 0.12 to predict the number of years before the population of orchids reaches 1850. So first of all, let me rewrite the model now that we know what a is. So I'm going to substitute 0.12 here. So I get 2800 times 0.12, which gives me 336. And then I've got the e to the 0.2t on the end there. Divided by 1 plus a e to the 0.2t. So this is the same thing as this, but with a being 0.12. I now need to predict the number of years, so find out what t is when the population is 1850. So let's make 1850 here. Let's solve this equation to work out what e is going to be. So first thing, let's multiply both sides to get rid of the fraction. So 1850 times 1 is 1850. Then 1850 times the 0.12 e to the 0.2t is 222 e to the 0.2t equals 336 e to the 0.2t. We're then going to subtract the 222 e to the 0.2t away from both sides. So that's going to give me 1850 equals 114 e to the 0.2t. We are now going to divide both sides by the 114 so that we get the exponential by itself. Now we're going to take the natural logarithm of both sides to get rid of the exponential. So I'll get 0.2t is equal to that logarithm. Now to divide both sides by 0.2, or times both sides by 5, same thing. So dividing both sides by 0.2, I'll get 13.93 years. So I'd say that t is 13.93 when the population is equal to 1850. Part C of this question. I now need to show that P is equal to that. Well, let me just get my updated model back. Let me just rub this out like this. So I need to show how this model here, how does that become this? Well, what's the difference between them? Well, my model has got a 336 on the top. Theirs has got a 336 on the top. But mine has got this as well. So how can I get rid of that so it's not there? Well, that's making me think that maybe I should divide the top by e to the 0.2t, because that way they all cancel out and just leave me with the 336. Is that consistent with the rest of the formula though? Because if I divide the top by e to the 0.2t, I have to do the same thing to the bottom as well. I can't just do it to the top. So on the denominator, if I divided 1 by e to the 0.2t, that's like me saying 1 over e to the 0.2t, which would be e to the minus 0.2t, which matches up. That's good, like that. And then if I divided the 0.12 e to the 0.2t divided by the e to the 0.2t, then these would cancel out and just leave me with the 0.12, which is good. So actually this idea of dividing the top and the bottom by e to the 0.2t is good. That's going to work. That is going to give me 336 over e to the minus 0.2t plus 0.12. So that is part C of the question. And finally part D, hence, so using what we just did, show that the population cannot exceed 2,800. So no matter how much time passes, as t tends towards infinity, as it becomes a huge number, what happens to the population? So let's see here. As t tends towards infinity, e to the minus 0.2t, I know that's going to tend towards 0. Because think about what that graph looks like. The e to the minus t graph looks like this. It gets closer and closer and closer to 0. So, if this part here tends towards 0, then the population, P, is going to tend towards 336 over 0.12, which is 2,800. It's going to tend towards 2,800, but it's never going to actually reach it. So therefore, the population tends towards 2,800, but will never equal or exceed it.